Hello, everyone. So I am OMERO, the communication assistant of France-BioImaging, and I'm happy to be here today to share the second edition of our webinar series, FBI Connect. Briefly, for those who don't know, France-BioImaging is a national research infrastructure in biology and health, and dedicated to microscopy and bioimaging. It's organized into 10 local nodes across France, as well as one transversal bioinformatics node. Our mission is to provide researchers with access to cutting-edge imaging technologies available in our core facilities, along with high-level scientific and technical support. And for the second edition, we are pleased to receive Guillaume Gay from the Laboratoire d'informatique, de robotique et de microélectronique de Montpellier within the FBI Montpellier node. Guillaume is a member of the ICAR team where he works with Emmanuel Faure on a smart microscopy project. And Guillaume is also a member of FBI.data project dedicated to computational analysis and handling of image data. He is the technical lead of the team and of the Bioimage Cloud project. He is also involved within the bioimaging community efforts to facilitate fair life science research data management. Today, Guillaume will present an overview of Bioimage Cloud, an imaging data management solution developed by the FBI.data team. Bioimage Cloud has been progressively deployed across the France-BioImaging nodes since May 11th. So if you have any questions during the presentation, feel free to post them in the chat at any time, and I will read them at the end of the talk when we'll have a dedicated live session of questions and answers. And now, over to you, Guillaume.
Thanks a lot. Thank you, Marine, and thank you a lot for setting this up. Okay. Yeah. Is it okay with the screen?
Yes,
I can go
it's okay.
full screen. It's good?
It's good.
Okay. So thank you all for being here. It's nice. Thank you again, Marine. So Bioimage Cloud is opened. We have the get-go, the green light from the security officers of CNRS to open the service to the public. So it's nice. I'm going to try to give you a quite high level overview of the system, and you can ask any technical question you have, and we'll dive in what seems interesting to you. So first thing first, the team of the FBI.data team of the project. So Perrine and Emmanuel are the mission officer for the project for the past 4 years. Guillaume and so Marc Mongy and Guillaume Mocor are the developers on the project. Guillaume is more on the UI user experience and user contact and so on side, and Marc is more on the backend dev. Théo Barnoin is the sysadmin of the project, is responsible for all the very deep technical stuff, and I'm Guillaume, I'm the technical lead and dev for the project. So the mission is to help researchers deal with their microscopy data. Research team, so you know, microscopy data is getting bigger and bigger. It's complicated to deal with. It's complicated metadata also. So so we try to answer or to help answer that big challenge that is producing microscopy data that's fair and open and that can be reused and so on. we also try to, doing this, we want to federate compute and storage between facilities and between users, because it's more efficient to have a 1 petabyte facility than 100 terabyte disks. And this scaling is important to seek for efficiency and ecology reasons. And yeah, we want to have fair data, and because it's the good way to have data, scientific data, and we want to make it easy to archive relevant data in public repositories. So to do that, we can try to set up a life cycle for the microscopy data. So of course we start on a research site, so usually a microscopy facility with a microscope that does some imaging that will get analyzed and maybe stored locally. And that's where we get in with Bioimage Cloud, with a step where the user fills up some kind of document to register its data. The data is organized in a data set, and imports it and sends a request for import into Bioimage Cloud. And the first step of that import is that the data will go on the campus, so somewhere on the campus, on a collection buffer, on a collection server that will just copy the data. It's supposed to be close to the microscope, supposed to go fast from the microscope to that local campus storage. And then the data is distributed from the campus to a regional data center with distributed storage. And in a fifth step, once the data is imported into OMERO, is available through iRods in distributed storage, we can do compute, and eventually, of course, publish the data so that it can be used in challenges, such as the one organized by France-BioImaging. And if you want to contribute data to Dorian, please contact him. He's always happy to get more data for his challenges. So publish to the Bioimage Archive, which is the public repository for this kind of data, and use in projects such as AI for Life as training data sets and so on and so forth. So that's what we try to achieve. And this is not easy, and to do it to ease our life, and we think also to ease the researcher's life, we base the work on standards. The first standard is a way to describe metadata associated with biological images. It's called REMBI. If you haven't heard about REMBI and you're listening to me now, you should look up REMBI. So it's a way to organize basically the metadata, not only the image acquisition parameters that are quite well saved from the microscope to the images themselves, but also specimen, biosample, study components, and so forth. So this today, and it's quite new, has been very quite well formalized with a standard format and so on and so forth. Just those last months, it's now coalescing into something that's rigorously defined to describe those metadata. And similarly, and also to simplify our life, we work with the ISA framework, so investigation study assay. So the idea is that if you use our services, if you have data somewhere, you have to tell us how to organize your data into an investigation study assay hierarchy. So with the publication and the people at the investigation level, maybe the samples, the biosample will be described at the study level, and the assay will be one pack of data with coherent experimental conditions, the same sample. So it's one acquisition set, one data set. So this organization makes it easier for us to transport and to organize the data. How does this go? This goes through a transport system. So it's kind of a metro or subway system for the data. The idea is that you start, of course, once again at the microscope. And we will set up on the campus, we'll set up a collection server with various services and the first of those services is an FTP server that's opened to the research site, okay? So you log in with an FTP client such as FileZilla or whatever, and you upload your big data. So this is on the research site, this is close to the research site, either on premise or somewhere nearby on your campus. And then the data is processed through a route. So the idea is that first you put the data on your FTP space on the server, and then it's from the get-go organized in an ISA hierarchy. Then we use some OMERO tools to look into the data, say what's an image, what should be a file annotation, that kind of stuff. And then, for example, as the first route that's available, we put it in some federated storage on site. And this federated storage can be displaced at will in a manner that the user is unaware of on different places, depending on where data storage is cheap, for example, or that kind of question. And then from that distributed storage, it can be imported readily into an OMERO server. And then you can access the data through OMERO Web. You can access also the data through a service that connects to the distributed storage. And so that's one route. So you get from the data into FTP, into the local campus buffer collection service, and then your data gets federated and imported into OMERO. That's one route. What we hope is we'll have many routes available in the next few months, as you'll see in a moment. So yeah, that's the essence of the service. What's complicated and absolutely not shown here is that each time you get out of one site, you have to get out of a local network. And each time you get into one site, you have to get in a local network. And those network boundaries are quite complicated to bridge. Because you have to convince some local ITs. Sometimes there are three IT services that contact to get this tube to get here, for example, and so on and so forth. So this is the work of Theo. I'm not talking about it in details here because there's not many sysadmins in the audience, I think. But that got us occupied those last 4 years quite a lot. My work was making sure the data goes safely from point A to point B as specified by the user. And so we developed a tool that's called OMERO Quay to orchestrate those workflows. So some examples of data data routes that we want to have. So this is the one I showed you. I didn't talk about the Excel part, but basically to get the metadata, you have to import an Excel that goes through a local authentication, and that will trigger the import of the data that's in the FTP server. What we support also now is that you can also import the data directly into OMERO from a client or the API. And what's important to us soon is do the compute and use the new techniques as OMEs are. If you have questions, if terms are not clear, if I talk about something that's too technical, don't hesitate to ask. Two routes are important. So OMER is very important because OMER then is very efficient for very big data because it's cloud native, it's chunked, so you can consume the data without needing a local copy. So that's super nice. Super important, maybe less on the practical aspect for the users, but for us, is that now we have, so allocate here is the standard I was talking about on how to specify metadata and sort the data. So allocate is the new standard, is now well specified for microscopy data. So we hope to provide an easy way to go from our data to allocate, either locally or or directly on the Mesocenter. And similarly, as I was saying, make it super easy to export to a Bioimage archive the data that you deem valuable enough to be published, or that's associated once it's associated with a publication. So here is the current deployment. We have two data centers. So the yellow part in Montpellier and Nantes. And we basically drew a line across the empty diagonal in France. And southeast of that line, it's Montpellier. Southwest of that line is northwest of that line, it's Nantes. So Bordeaux, Nantes, the IRS at Nantes, the IGDR at Rennes, Prima Seine in Rouen. And then we have four collection servers in Paris and Saclay, one in Strasbourg, one in Lyon. There's one in Grenoble coming up, one in Lumilly. There's one in downtown Marseille. I don't remember the name of the site. Sorry, by Arnaud's at Arnaud's place coming up. Two in Montpellier, one in Toulouse. And there's one in Lille. So the one from Lille and the one from Latimon are not managed by us, but by our collaborators. So in Latimon, it's Arnaud Le Trotteur for the Omics project. And in Lille, it's Carl Ulmi and his team. And it's not a project, it's just that they want to join the network. Here is how it's we wish to organize the service in when it's in production, now that it's in production. And the idea is to have several roles, several people fitting several roles depending on where you are. So as I said, the research site is the smallest unit of organization. And people will belong to a research project, an investigation. So as I said, the investigation is where you say which people do what. So one investigation will go do images on a research site and import it in a campus, and then the data is transported in the Mesocenter. And so for each investigation, we'll have analysts and microscopists, and we'll have a team data steward. And the team data steward is very important because it's the person that will drive the ISA organization, drive the choice of vocabulary, or get a bit more competent than his colleagues on research data management, so that he can set up for now, for example, an Excel template with most of the data, or Excel templates with most of the metadata already filled in for his colleague to use, and so on and so forth. So the team data steward is really key at the lower entry point of the solution. Then at the research side level, we'll have the platform staff, who are, of course, super key, because they will expose the solution to the users. They will point the users to the documentation, to training resources, and so on and so forth. We have a data correspondent at the research site who will be a member of the facility staff, I think. And then, of course, a security correspondent at that site. And at the campus site, we have the data contact. So in French, it's référent data, except référent doesn't have a very satisfying traduction in English. But so we have the data contact and the security contact at the campus site. The security contact is the person who's hosting the collection server. So he also has to be super aware of what's happening. And so both security correspondent and contact will sit in the security committee or be represented in the city committee. All the other personnel will be sitting in the user committee, where we can discuss what feature is the most useful, what bugs, how to share, how we work with the system, and so on and so forth. So that's it. Oh, I miss one I haven't compiled it yet. Wait. Let me just update the. Yep. Okay. Sorry for that. I think there was. No, there's not. Okay, there's not. I thought I had a conclusion slide, but I don't. Sorry. So no, that's it. Just yeah. So as a conclusion, or for the real project, or the real perspective is there is all the work we are trying to achieve this year. So compute and OMEs are our priorities right now. Trying to expose a Jupyter notebook, for example. What we want to do is now listen closely to you, so that you try the system and we try to fit the system to what you need to your workflows. I haven't shown it, but the system is quite easy to hack. Not to hack in a malevolent sense, to use with the Python interface. So you can use it through Python. You don't have to use the web service directly. You can use it directly through Python. So what I hope is very standard workflow. If you have in your facilities or in your work cases very standard workflows, those could be automated to go directly into the solution without you having to fill in an Excel file. So yeah, the idea is this year we need users, so we need to make things that please and help the users. And for this, we need to know what you need. So that's it. And I'm going back to my thank you slide. I should put a big list of names. It's time I try. After like 12, I get tired. So I say many thank you to you all. It's very, very, it's nice to work with nice people. I don't know how to say this differently. And now but yeah, now we can answer questions. Thank you.
Okay, thank you very much, Guillaume, for your presentation. So it's time for questions and answers. So if you have any questions, you can raise your hand and I will give you the floor. Or you can write your question in the chat as you want. So maybe while we wait for your questions, I can start with mine. Guillaume, do you have an example of the Excel template to see
Yes.
what we to fill?
So straight to the. So I need to stop sharing. It's in
Because
so,
the main contribution of the users is to fill the Excel sheet.
yeah, absolutely. Okay. So now see if I know here documents, Excel, this TCB facility. Okay. Can you see the LibreOffice opening? Yes.
Yes, it's dark. Yes, yes, it's okay.
Okay. So it's a bit ugly, but the idea is that most of those information you have to fill in once, and then you. Okay. So basically, we have three tabs. The first one is the sheets. Sorry. The first one is the investigation. So this should be your big research project. And we have few data to put here, the data stewards, and only the data steward is authorized to create investigations because it's our point of contact to buy and sell storage quotas. Storage management goes through the team data steward. So we have to point to him explicitly in the Excel. The author of the data, so is the person who basically was at the microscope or prepared the sample. There's one person that was on the Excel that's not anymore. It's the data manager. It's the person that is doing the import. The data manager is, for example, is for the use case of electronic microscopy facilities where the author of the sample is not the one who is taking the data, and the one who is taking the data will push the data on behalf of the author. So that's often a facility staff in an electronic microscopy facility will go through the workflow on behalf of someone. So in order to take this into account, there is a role of data manager, but it's implicit because it's the person who's logged into the FTP or logged into the dashboard. Here is what you copy paste from your research project or the abstract of the paper or I don't know what. And the root is what I was telling you, the way to where you want to put your data. So for now, it's only default. And in the documentation or in the templates, you'll see the one you need to take. So this will be, for example, from CRBM to Montpellier, to the Meso Center in Montpellier. The study is also quite thin in its description. It's a description, a name for the study, and some tags that will get into OMERO. Maybe later on, the sample information will be there. This is subject to change this year as we fit more the metadata standards or the user's workflows. But basically, the study doesn't have to be very detailed, and then it's in the assay that there's the most data. So the idea is that for each of the data you've acquired, you do a folder, you put all coherent data in a folder, and you will say, I want to import the content of that folder into an assay. Then you upload that folder into FTP, and you copy paste the path to that folder from your FTP client. So that's the thing you have to do each time you have new data is that copy paste the data, the path to the data on the FTP and associate it with an assay. And as you can see, you can have several folders, input folders for the same assay. This might be the same sample or 3 experiments, but with exactly the same conditions, but at different times, for example. They will go in the same assay, but they are not in the same directory when you import them. And then we have a lot of the metadata here. So a description, the parent study. So here you say, okay, this figure 1A will go from needs figure 1, so I can copy that and put it here, etc., etc. So it's a bit of copy paste between the 2 sheets. So once again, we know how it's organized in the ISA, tags, and then all the rest here. So I'm sorry because the length of the are too bad or too small. So we need the organism's scientific name, except if you do metrology. If you do live imaging or if you do biology, basically, we need either the scientific name or the common name or the NCBI taxon. So this is requested now by REMBI. So we'll try to insist on the user putting this up from the get-go because the very minimal metadata is what organism is in these images. And then you have several metadata. So biological entity, this is detailed in the RMB publication and so on. So and it's detailed in the documentation of the paper. What we would like to have is so it's not well, it's not in the right place. Sorry. What imaging method should be here? Sorry. What we hope is that with a Matbot, we can get rid of the Excel file and have something that's more user-friendly than that. Yeah, what we would like to have is the imaging instrument and the imaging method, basically. Also, the imaging instrument is interesting for the facility personnel. So basically, what we would have is the facility staff will give us a list of instruments, and you can do an Excel template for your users that will choose the instrument they use. This is good, but it bridges a gap between OMERO and the microscope that was used to create the data. It's not that easy to track the instruments. So yeah, I hope this gives you an idea. What I can do is maybe try to go to the dev server. I'm not sure it's up. So no, it's not up. I can put it up, maybe. If you have question, I'm starting the.
Yes. Could you hear me? Yeah.
Yeah.
Yes,
I have maybe you mentioned it, but so in the map you presented like this cycle. They are like the campus, the one in Paris-Saclay, for example.
Yes.
And if
Yes.
I am in an institute close to Paris-Saclay, and I'm FBI, I can save my data on this campus.
Exactly.
Okay.
The idea is that you either you're on the same site as the service, or you have the secure. Basically, you write an email to the data contact or to us, and we'll contact the security contact that will contact your IT and open the FTP port. Basically, it's just an FTP port, so it's not that much.
And is there a limitation of data we can save on this campus and in this mesocenter?
That's a very good question. The idea is that so those servers those are the server we could buy 2 years ago with a budget. We had money left, if you can believe that this happens. We had money left. And so we bought 12 machines, basically, and those machines are hosted in the different campuses. They have 30 terabytes, basically, of data, but they are just a buffer. So the idea is that you fill them during the day, and they get emptied out during the night to the mesocenter, where we have much more capacity. Okay. So for 2026, to answer concretely, for 2026 is the year is blank, so we don't count any storage this year, just because we don't have an idea of the adoption rate, the volumes, and so on. Starting 2027, I think if you need to store more than 2 terabytes or 1 terabyte, or I don't know, of data per year, you'll have to buy that storage. And the idea is that we'll be an intermediary between you buying storage to the mesocenter and us setting up a quota. Basically, you buy storage to a mesocenter through a public through your institution and their institution. They do an invoice and so on and so forth, and they tell us that Data Steward bought that much space, and we associate it with your investigation. So we do the bookkeeping of what investigation gets access to what storage, but paid by who, basically.
But this will be more than 1 terabyte. For less than 1 terabyte, it's free.
For less than 1 terabyte, we should absorb the stuff. But Emmanuel, I hear Emmanuel. I think that will
just a compliment, because it's not buying a terabyte; it's renting. We rent terabyte to the meso centers, so you will have to rent it per year, okay, depending on the project, etc. Just a precision to be clear.
Yeah, you're right.
And Guillaume is completely right that we don't really know the adoption factor during this year, so we will try to set it free for everyone, except if someone uploads 100 terabytes in a day, it will be complicated for us, okay? But we'll try the maximum. We also have money until 2030 in both meso centers to pay bills of average, let's say, usage, but we don't know what is the average. We estimate that it's a terabyte, but if the adoption is very low, we could offer more. If it's very high, we will maybe decrease this terabyte. So this is very a factor that we don't have many ideas. But what is sure is that we will always try to ask grants to pay as much as we can a terabyte supported in the meso center. Okay, and so if you are interested, if you know your closest meso centers, and sometimes they ask for a project, we could help you to ask money into meso centers with the signature of France-BioImaging. Sometimes it's interesting to ask storage, etc., etc. Many meso centers are open to this type of grants, so don't hesitate to ask us if you need help on that.
Thank you.
Thank you, Emmanuel and Alice. Maybe we can continue with the questions because we have some questions in the chat. Guillaume, you can see it too.
Yeah.
Questions on management of sensitive metadata and questions on the Excel sheet. So I let you answer.
Absolutely. Both good questions. So thank you for questions, Emna. Define sensitive. All this happens in an authenticated space. So anytime you get on the system, you have to authenticate through your Renater ID login. So only members of the team see the data and the metadata. It's the same for both. We cannot host health data, or we can't promise if like you want to use our service as a vault for your very sensitive data because there are IP question or industrial applications or whatever. That kind of stuff, we can't promise you your data is at that level of security. So basically, when we went through the homologation process, the security homologation process, we had to define the scale of sensitivity of the data, and we are kind of a compromise. So when you put data on the system, we do our best so that it's only visible by your colleagues, but we can't guarantee a super high level of security because if not, we'd need to be like we'd need 2 more people just to do that. Plus, it would be super not friendly for the users because you'd have to log in only on some places and so on and so forth. Here, as the data is exposed on the internet through a login, but from everywhere on those endpoints, we can't guarantee a super high level of security. But it should be safe enough. for at least for your research, so that your colleagues won't spy on you. This we guarantee. So the access to the data and metadata can have, now we have a lot of endpoints for the data and metadata. If you have the use case, you can ask for an iRods directly access to the distributed storage from your research site. So this is nice if you have to copy the data locally after import, because you want to use it locally or because you want to analyze it locally. You can access the data through the OMERO API, through the iRods web client, or through the API from the research site. And hopefully we'll expose high performance computing services, so you can compute on the data without moving it, and so on and so forth. So there are many entry points to get the data back. Of course, once we have OMERO implemented and it's S3 storage, the access to the data will be even more efficient, and hopefully we can expose S3 endpoints directly. So directly the ZAR data URL outside, but this we don't know very well how to do yet. We know that OMERO, I know Sebastian is here, Glencoe Software build the stuff to do this through OMERO, so maybe we'll use that, but it's not clear yet. Fred, thank you for the question. How the ISA Excel information are transposed to the project dataset architecture in OMERO, if imported there, and how is it specified it should be in OMERO or elsewhere? It's OMERO by default. So the route now is OMERO, so that's the default route. And investigation is a project in OMERO, a group in OMERO. Study is a project in OMERO, and assay is a dataset in OMERO. What happens is that the data steward is the only one that can ask for a group, but is not group admin for the OMERO users for the OMERO aficionados. The data steward is not group admin, but is just a group owner. So the data steward will update the users in OMERO. So for now, our edition interface for the who's participating is through OMERO. Let's see, yeah, I'm going to try to import data. Oh no, but I have bugs. I'm debugging right now. So. How do you make HPC connection to the data store in OMERO? No, it doesn't work. Okay. So how do we go from here to there? There's something called Bioimaging, developed by NL, by Bioimaging Netherlands, that makes it easy to expose jobs, some jobs from OMERO. So we hope to rely on that. We'll try that. I think, nonetheless, we'll have to do a copy from iRods to the scratch of the HPC, but it's not clear. But I think we'll have to copy on the HPC scratch volume to do the compute. But hopefully we can hide this from the user and make it directly from the OMERO web with the Bioimage plugin.
Thank you, Guillaume. Maybe Laurence Berry can ask questions.
Yeah, there's a discussion. There's a there's a post on ImageSC forum about that. I'm super interested to hear from you what metadata you want to save, and if you leave me, let me search the forum. Oops. I think, yep. I think it's this discussion. Sorry, my network is a bit slow. Yeah, so I think that's the current discussion on the subject and the matter. Yeah, it was here. So I can post this on the comments. So that's the image essay about this. The idea is that everybody is converging really on an arrow-crate profile for microscopy images, on OMERO for the data format, and or on something more for the rest of the metadata. And the OMERO specification for now is not super hyper clear on the matter. I see Sebastian has a risen hand.
Yes.
Maybe you want to comment.
Maybe can you hear me?
Yes,
Yeah.
can hear you.
In fact, I have two kind of concerns. The first one is about metadata formatting, because the useful parameter are quite different from light microscopy. So I think we need a template, something like a template to fill in. And my second problem, which is not really personal, but I don't know if it's universal, but with Zeiss electron microscope, the acquisition software is not really belonging to Zeiss. And currently, it's totally impossible to export the metadata regarding the acquisition parameter.
Okay.
So it's a big issue. I don't know how, Nicolas, maybe, I don't know if it's the same for Thermo. I don't know really how to deal with that. Because the only way we have for the moment is to simply write it manually.
Okay, but that's not sustainable.
Yeah. Nico, it's the same for you or not?
Oh, he answered in the comments.
He has left?
It's not automated to get the metadata. Also in TFS. What's TFS? TFS? I don't know.
I think it's Thermo Fisher, yes.
Thermo Fisher Scientific.
Well, I think the canonical answer now is pressure the vendor to make it so that you can export the metadata. Because basically the argument is we need the metadata to publish. If you don't make it easy for us to get the metadata, you make it hard for us to publish, and it's a problem. But I don't know how it's complicated to convince the vendors. So I don't know. Just to give you just an alternative answer to that is that we can always just organize the data in ISA, give whatever metadata is accessible to you, and make a zipped archive, archive, yes, and put it in some storage so that you just have access to the data without it being imported in OMERO and all the fuss. But it's a bit sad to do that, but we can still do that. So if your data doesn't fit in OMERO because it's not correctly maintained or correctly interpreted by bioformats,
no,
it's
not exactly the problem, because we can always export the images by itself in TIFF, for example, or something else. So the fact to have the data accessible on the server is not a problem. But in the exported TIFF, there are absolutely no information about the acquisition parameter. Yeah. It's not encoded, it's not encrypted, it's not there.
That's bad.
So we have very little. We have the microscope model, the pixel size, and the image size, and that's all for my part.
Wow. So yeah, I don't know. I don't have a solution for that. I think yes, it's like your so either the scientific society or pushing maybe in founding guides or your bioimaging or the national infrastructures to pressure the vendors of the software, telling them this is not acceptable. You should provide us with this and that metadata. You can rely. I mean, there are various white papers on minimal metadata for. I think there is a white paper for minimal metadata Yeah, or you can be Tom Boissonnet and write the parsers and try to write Python scripts, but if it's not encoded in the file format, in the proprietary file format, and not possible to extract from the proprietary file format, it's a problem. You must pressure the vendor through your scientific societies or the scientific organization to conform to open science, well, to what's asked for. Simply for publication, I mean.
Yeah.
Sorry, I don't have a better answer.
I think individual pressure is useless,
No,
especially
it's
when
not.
you already own the device. You can discuss if you want to purchase.
Yeah, that's the best moment. That's for sure.
Something could be maybe done with bioimaging, because I think in other countries it's a problem.
Maybe it's the correct scale. So I can at least like raise the alarm or something like that.
Yes, please. It's a good idea.
Okay.
Sebastian, you have a question, and maybe it will be the last one.
Okay. Thank you. Thank you, Guillaume, for a great presentation. I mean, I think we started talking about this project a couple of years ago, and it's really cool to see it coming all together. And you mentioned also the Dutch community, so it's nice to see that like France is also organizing at this national level. It's super cool. I have a question regarding, I mean, that won't surprise you, object storage, because you've got these, and I know it's the next step. So you've got this nice logo, which is an Amazon logo. And I'm like, so
yes,
are you what's the plan? Is this object storage something that will be held at the Meso Center again? Is it a hosted center, or is the data going to be hosted on third-party object storage? Do you already have a plan for how this is going to work?
Yeah, so usually the S3 storage is from the Meso centers. So from the publicly owned data center. We don't plan on plugging into AWS or whatever. They are cheaper, I think. Emna, who's there, like went around asking prices, and so the price of storage, either S3 or HDD or drives or file system storage, is around 40 or 50 terabytes a year or less. So it's looks cheaper than the public one. We could rely on I think we could rely on French hosted NumSec Cloud, SecNum Cloud approved object storage providers, but for now it's really from the data center. So yeah.
Yeah, just to add maybe a compliment also on that. In France, the government asked us to go to put the data, at least for research, to the Meso Center, to the local Meso Centers. So that's a local national volunteer. And if we go in this direction, we get some money. If we go in another direction, we not be supported by the government or by the institution, etc., which makes sense in many ways. Yeah. Except the price.
Yeah, there's an obvious question of, I guess, I mean, sovereignty and all of that, right? Yeah. I mean, and that's true for a lot of things. I mean, I'm mostly mentioning because it's an interesting transition. Again, we worked on the Czar and cloud connection. Initially, all the work we've done was like on Amazon, but it was mostly because of people who needed that were in the US and they're using Amazon. And the more we start working with French, I mean, in general, European, and there's probably a European effort to get like an European provider that would be a competition of Amazon, but they want their own solution. So I think all of that is technologically completely feasible. I mean, it's, but then that would be a private object store, right? We're not talking all like public object store data, because that's still pre-publication workflows.
Yes, exactly, absolutely. I think once it gets into Bioimage Archive, then it's public S3, and I think what we can do, but I have to is, well, everybody gets a token. So we can do token-based access to that. I think not in a not very complicated fashion with the authentication layer. I think the authentication layer can filter access to those S3 endpoints, which would be super nice. But yeah, we'll see in a few months. Answer in a few months.
Thank you, everyone. It's time to end our webinar. So for your information, the presentation will be available on YouTube. If you want to watch it again or share it with your colleagues. I put in the chat some useful links with the contacts of Guillaume and of FBI.data. You have also a documentation about the solution, which is very useful and quite easy to understand. The link to the identification portal to create your account. The team organizes also open desk sessions every Monday and Wednesday to help you get start with Bioimage Cloud. And the team has also created a mailing list about the different updates of the solution. So don't hesitate to contact them and to take a look to the documentation to help you. And thank you very much, Guillaume, for your work and for the work of the entire team. It's a wonderful solution. And thank you for coming today. It was a great pleasure to work with you on this event.
Thank you all. Thank you, everybody. Okay.
And for everyone, bon appétit.
Bon app. À bientôt.
Merci, à bientôt.
Au revoir.